Hello, 7th graders. It's Mrs. Sullivan. We're going to be working with section 6.4 today. It's surface area of pyramids, pages 272 and 273. As always, you will need a pencil and definitely a calculator. So pause and run and get those things. And welcome back. Okay, we are continuing with surface area. This time, though, we're working with pyramids, which are commonly confused with triangular prisms. But we're going to clear that up right now. So we have right here a definition of a rectangular pyramid. It says it's a pyramid whose base is a regular polygon. If it's a rectangular pyramid, that means its base is a rectangle. If it's a triangular pyramid, its base is a triangle. If it's an octagonal pyramid, its base is an octagon. And it says the lateral faces are triangles. The height of each triangle is the slant height of the pyramid. We'll clear all that up when we start drawing some pictures here. So the surface area, often symbolized with a capital S, of a pyramid is the sum of the areas of the base and the lateral faces. So just like what we've already been doing in class, we're going to be doing this, drawing some nets today, and we're going to find the area of each of the pieces and then add them all up. That would represent your total surface area. So let's get started with our first example. Here we have a square pyramid. I know it's a square pyramid because the base, or the bottom, is a square. I'm going to do some artwork for you. Try not to be jealous of my sweet abilities. So the base is a square. So I'm going to draw that square, and I'm told that it's 5 by 5. And you'll notice that there is a triangle coming off of each side of the square, which means we're gonna, if we were to open this up, we would have 4 identical triangles. Use your imagination and pretend they're identical. All right, now we just need some dimensions to go in there. Can't not connect that, there we go. Okay, so it says here that the height of each of the triangles, and they're all identical, is 8. Okay, now all we need to do is find the area of each of these pieces. I'm going to use a different marker. So remember that the area of a square or a rectangle is always just length times width. So 5 times 5, which means the area of the centerpiece is 25. Now, if each of these sides of the square is 5, then the area of each of these triangles is going to be identical. This side right here is 5. Remember that the area of a triangle is base times height divided by 2. So that means we have 5 times 8 divided by 2, which would be 20 divided by 2. No, it would not be 40 divided by 2. Sorry about that. That's 20, which means that the area of each of those triangles is 20. And then this becomes one big, huge addition problem. You could do this several ways. You could add them up each individually. You could say that 4 20s makes 80 plus the 25 that's there. When I add these up, I get 105, and I'm dealing with inches squared. So the final answer to that one is 105 square inches. The idea is the same. We're just finding the area of each piece. So that was a square pyramid. Look up at example 2, and we have a triangular pyramid. All that means is that the base or the bottom of it would be a triangle. So we're going to be dealing with some different triangles here. So if you notice, the very base of this has a base of 10, and the height is 8.7. So I'm going to sketch that one out here. This is 8.7. Then I have triangles coming off of each side of this, which means I'm going to have 3 other triangles. Those 3 triangles will be identical to one another. Look how pretty. All right, so each of these is a 10, but the height of each of these triangles, you'll notice, is 14. All kinds of numbers. I hope you're listening and not just writing these down, because that would be very confusing. Okay, so now we have to do some calculations here. So all of these are triangles, so we're going to need that base times height divided by 2 for every single one of these. So for the very base, the middle, we have a base of 10 and a height of 8.7. So we need 10 times 8.7 and then divided by 2. Type that all into your calculator. It turns out to be 43.5. So that's the very bottom. The other three triangles are all identical, and they have a base of 10 and a height of 14, which makes 140, but then remember we're dividing by 2. So that's 70. So now we need to add up all these pieces. So if this one is 43.5 and I have a 70, a 70, and a 70, 3 70s makes 210 plus the 43.5. Add those up and you get 253.5 meters squared. If you prefer to write one big problem that says 70 plus 70 plus 70 plus 43.5, same thing, you should end up with 253.5 square meters. All right, last example. This one's fun to say. It's a pentagonal pyramid. That just means that the very base is a pentagon, a 5-sided figure. And we don't have a formula to give you for the area of a pentagon, so we are so kind and we're just telling you that the area of that base is 82. So you don't have anything to calculate other than these triangles. And since our base is a pentagon, which has 5 sides, looks kind of like home plate, that means that there are going to be 5 triangles coming off of this. And they're supposed to be the same. Not quite sure what this is. Good times. Okay. Very interesting. Okay, so we know for sure that the area of this is 82. But what we don't know is the area of each of our triangles. But we do know that the base of each triangle is 8, and the height of each triangle is 14. So that means using base times height divided by 2, we would do 8 times 14 divided by 2. Type all that in. That gives you 56. And I have 5 of those. Each of these is 56. So I could just do 56 times 5 to give me the area of all the triangles. That would be 280. Or you could line up 5 56s if you wanted. We need the 5 triangles and the original pentagon. So I'm going to take the 280 from the triangles plus the 82 from the pentagon. I'm going to add these up and I get 362 millimeters squared. We will see you tomorrow.